Hello everyone, my name is Prateek Jain and I am from NVIDIA Inception team. So firstly, let me quickly brief you about how we are supporting tech startups across the globe, and further my colleague Ninad will take you through the robotics workshop. Right. I hope all of you might be aware of NVIDIA being a technology company and supporting the startups in AI and semiconductor space, right? Now, let me also quickly brief you about the tech stack because most of the times people feel that it is only a semiconductor and hardware company, but we are way beyond that. So if you see, there is system software wherein there is RTX, CUDA, and SciX, and then on top of it, there's an platform like Omniverse, high performance computing, and also artificial intelligence. And on top of it, if you see, there are application frameworks, which is, for example, Mona is for healthcare, Riva is for speech, Drive is for automobile, ISEC is for robotics, and so on and so forth. So most of these startups, they use these application frameworks and build their solutions on top of these frameworks, right? So just wanted to give you a glimpse of the tech stack. Now coming to the Inception program. So this is a global program wherein we have more than 20,000 startups currently part of the program. And in India itself, we have 1,700 startups. Now, this program is completely free. There is no fees, no equity involved. And the focus is on all the AI startups, tech startups who want to build their solutions, sorry, who want to build their solutions on top of NVIDIA platform, right? Now, I'll also show you, these are some of the starters which is part of our program. And you may see some of the names like Hugging Face, Rephrase.ai, there is Run.ai, in fact, Perplexity.ai, they are part of our program. And you might be already knowing how well they are doing currently. Now, what we offer in the program, these are the benefits which the startup get once they register for the program. They get a lot of free and self-paced courses from our Deep Learning Institute. The technical team and the CXOs, CTOs of the company, they leverage, go through these program, which is completely free once they are part of the program. They also get access to 150 plus SDKs, and we have partnered with AWS and GCP for cloud credits. They also get discounts on almost all NVIDIA hardware and softwares. And there is engineering guidance from our solution architects, from DevRels, and from our tech team. And we also have a VC alliance wherein we support startups in fundraising. So the alliance is having 900 plus VCs globally, and the startups who are looking to raise funds, we help them support in fundraising by connecting to the VCs. So these are the main benefits which we provide as part of the program. Now this I have already spoken about the Deep Learning Institute, preferred pricing, cloud credits, and developer tools. And the startups also get a lot of brand awareness, brand visibility. We host a lot of events at various conferences, various technologies. It's on NVIDIA website, and it's visible to all the industry experts, investors, VCs, and they can directly get in touch with startups by just clicking on the respective startup. Uh, yeah. Now, what's the eligibility criteria to be a part of this program? So there's basic criteria like the startup should be legally incorporated, should not be more than 10 years old from the incorporation, and they should have a functional website, and there's a full-time team in place and with the developer onboarded, right? So these are some of the basic criteria, and of course we look at how NVIDIA can play a role, how NVIDIA can support the startups going forward. If currently they are not using any tech stack, that's also fine, but going down the line, are they willing to adopt to any of the technologies? Are they willing to use any SDKs? And we take them in that manner, right? So that's, I think, about the Inception program broadly. If you are interested, if there are any startups are here, if you are interested, you can scan the code and it will go to the website. You can fill in the simple application form and it goes to the team for review. We also have a developer forum which is open to all the developers, students, and the community who wants to make the, I would say, career in AI, want to learn more about all these platform, latest advancement. You can be a part of the developer forum, developer program. All this is completely free. There is no charge to be part of the community. So I think, as I mentioned, the developer program and the VC Alliance, this is the developer program wherein the startups get access to all the XDKs, they get unlimited access to use the forum, and they can ask all their technical queries and questions in that, and our tech team will reply to them. So if you are interested, just visit developer.nvidia.com and you can register to the forum. As I mentioned, we do events like GTC, which is a GPU technology conference, which happens in US. Similar event we are doing in India this time in October at Mumbai. So if you are interested, do keep visiting our website. We'll share the registration details shortly, and you can leverage a lot of benefits by attending these conferences. So I think that's about it, and now I would like my colleague Ninad to further take you through the robotics session, how NVIDIA is as a robotics. We have a dedicated, I would say, field, and how we are supporting. So he can take it forward. Yeah, come. Thank you. If you have any questions, I am around. Feel free to ask. If now you want to ask, you can also ask, like if you have any questions. Thank you.
So, hi everyone. I'm Ninad, solution architect from NVIDIA. Basically, I work with edge and robotics devices. So, this event, since organized by aicra, Robotics Association, so that's why mostly I'll be focusing on how you can elevate your robotics game with the Isaac SDK. So, the agenda for the whole workshop will be like overview, the training, the simulation, the runtime and workflows, and how you can put hardware in the loop with NVIDIA Jetson. So if anyone is aware about the NVIDIA Jetson devices, so I see many hands raised there. So yeah, NVIDIA Jetson is one of the most powerful computing platform at edge that we have currently right now. So whenever we feel that the compute is not matching, like we always try to target those kind of atmospheres or those kind of compute scenarios where the industry has not yet reached. Like earlier, 20 TOPS was enough for you to run an object detection AI model. But right now, the generative AI scenario has started, and the clients and the customers of many startups, many edge startups, has started asking, how can we interact with the machine? Without interacting with the machine, there is no output right now with traditional AI models. So what NVIDIA Isaac Robotics platform has done for you, they have started this go-to-market strategy and reached how you can start your startup without any fundamental flaws. You can start your startup with foundation models. It has like 50 plus foundation models pre-trained for you, and you don't have to like spend a single penny to train a model. It's already trained on an internet scale data. It has like 70 billion parameters, and these parameterized, heavy parameterized model, you can also interact with them. So we have our project, you can see the foundation pose, the foundation grasp, the Groot, the VIA. So these are some of the models that are recently launched, and if you are working with ROS, Robotics Operating System, then you can also integrate these fast accelerated libraries inside your robot. So how can you do that? You can do via Dockerized container environment. What we have provided is Isaac Lab. Isaac Lab is a full containerized environment where you can train machine learning algorithms for your robot, where you can train deep learning algorithms for your robot, where you can train reinforcement learning algorithms for your robot. So you can actually elevate the game using Isaac Sim and Isaac Lab. Isaac Sim is based off an Omniverse platform. So you must have used Gazebo, whose like whoever is into robotics, they must have used Gazebo for simulation of the robot arms or robot AMRs. So similarly, if we want a real-time physics LiDAR environment, suppose we want the actual physics, the material, the polishing, everything, the wall reflections, the light reflections, the material densities, the softness, the dampness, these kind of parameters are not easily available on Gazebo. But Isaac Sim uses the physics which is accelerated through the CUDA libraries, and you can use these physics libraries directly and integrate your robot into the URDF file. Like you can export your robot in USD, URDF, STEP, CAD, Onshape, whichever file, STL files, any files you have of your robot, you can import it in Isaac Sim, simulate the whole environment. Like you can create a warehouse scene. Suppose you are making a warehouse robot, you can create a warehouse scene which is pre-built for you. You do not need to create the 3D assets for earlier to create a whole scenario. You need the 3D assets, right? We have provided you the sim-ready assets which are already there. Like you have the simulation-ready assets. You can directly import these 3D assets into the environment and start your robot's deployment and test the environment, how the robot will perform in the real world. So sim to real gap, there was always a simulation and real gap. So that sim to real gap has now been narrowed. So whatever the test results are in the simulation, you can actually see the results in real time, in real world environment, and without any drifts. Like many robots tend to drift after some slams, after some laps, but when we simulate these kind of stuffs, we know what after 3 laps, then we can write an algorithm that drift will not be there. So NVIDIA is trying the best how we can launch the models foundation pose. Like you have seen object detection, right? Always the bounding box are always squared. Why? When we rotate the object or rotate the like any object or a person, the bounding box also should rotate, right? Otherwise, how will the robot know that in X, Y, Z axis where the robot should focus on? So the foundation pose helps you to know the X, Y, Z axis of each and every object of yours in a conveyor belt or any pick and place robots. So you can easily integrate a like foundation pose into that, and you can know that the model, that object is getting rotated in the x-axis, in y-axis, or in the z-axis. So similarly, we have the jetpack. Jetpack is basically the OS on which your whole hard software will be running on. So we have the Isaac perceptor and manipulators. So the trajectory algorithms, when an robotic arm, you are trying to create a robotic arm, you have to focus on the trajectories. Suppose a robotic arm has to go from top to bottom. Then it has to follow a certain path. Suppose there is some obstacle in between. So you have that robotic arm should come down with a proper path. The trajectory planning should be proper. So we have provided the libraries like QMotion, QRobo, these kind of CUDA accelerated libraries, which can actually perform the real time with the shortest path. You can create the robotic manipulators arms, and you can create, like the trajectory has been planned in such a way that it will see which obstacles to avoid and which obstacles not to avoid. And we have launched this project Groot. Project Groot is basically a humanoid project, and we are working with top universities like Boston Dynamics, Michigan, and CMU, Harvard. So we are creating a unified foundation model, so like our similar to brain. So it will consist of many NIMs. It will consist of each and every, starting with object detection, starting with any generative AI algorithms, the perception algorithms, and the language algorithms. It is a humanoid project. So currently, Project Groot is also in place. And above all, there is Orin. Orin is basically, it will help you to get the generative AI capabilities of your bot into a particular environment. The Jetson Orin is such a device that it can perform the compute of a 70 billion parameter model as well, which is very rare if you want to create in a remote location any compute. So going ahead, this is one of the video where we are seeing the how Isaac Sim is actually working for many companies. So PCB defect detection, starting with robot manipulators. These are reinforced. You can multi-robot algorithms. You can train multiple robots at same time. So this is NVIDIA Robotics for you guys. Pardon me for my laptop has ran out of charge. But yeah, so what are the challenges that we regularly face when building an like robot basically? The challenges is the number one is connected environment. Suppose I try to create a robot, I need a CAD importer, right? Like suppose I created a CAD file for a like whole robot, and right now I want to import that into Isaac Sim or any gazebo. Then after getting that simulation, I need to get that bridge, like connect the ROS with, like ROS is for communication. There are three important aspects for robots when we talk about the robotics. The number one is the simulation. The second is the trained model. And the third is the communication, how we communicate with the robot. So these three parameters need to be connected. And that's why Isaac is the best way, where you can import all the things, starting from your machine learning to deep learning algorithms and your robot CAD models. Like we have a lot of importers. Your robot may be in whichever file, we can import it via our step importers, on-shape importers. We have USD importers. So there are lots of importers. And you can build your own extensions. You can train a multi-robot environment, and you can start the robotics game right out of the box. Once you have your simulation ready, you can get the ROS bridge. Like ROS to Humble is the latest one that we are upon right now, and building all the shutdown. So all the robotics that whole environment that we have built, you can easily import the robots into that environment and get it out of the box and running. So there are so many things, like there are blenders. Suppose you created a scene from Blender and you want to import it in Gazebo. It's pretty difficult, and you won't get the material reflections as it is. But this physics LIDARs, the physics sensors, the physics that we have developed, we have created that surfaces, that reflectors, the densities in such a way that the blenders, whatever you see in whatever is the output in Blender, that output should be coming into the your simulated environment, and so on. So discussing about the challenges that you are facing, I would like to know that what challenges that you are facing. And we can see that we have to test both software in the loop and hardware in the loop. So whenever there is software, like if you trying to build a reinforcement learning algorithms for a quadruped. So you have a quadruped robot, and you want to train, suppose you want that quadruped needs to step down from this, it can walk in the plain environment, but when it comes to steps, how can it climb down the steps? So you need to train that in a reinforcement learning environment. And that too, multiple robots will be there in one environment, and you have to create, like every robot quadruped will be given a certain task, it will perform, and based on the convergence, we will see how the reinforcement learning happens. And whichever robot gets the least convergence, we will say that this quadruped is ready to run in real time. So that's what NVIDIA does. NVIDIA tries to showcase the partners. We have a bunch of ecosystem partners, starting from sensors, LIDARs, TOF sensors, the RTX sensor, like everything that is compatible. There's a whole ecosystem out of it. And you can create a whole new different level of your, there are so many pre-packaged models, accelerated models that we have put up. There are foundation pose models. There are Isaac Ross to gem packages. Like there are so many packages that we have developed for you guys that is much more needed, and that latency will be like reducing the memory copy. So what happens is whenever we are trying to run an algorithm on any device, there will always be memory copy from CPU to GPU. So this memory copy creates latency in our environment, developing environment. So that's why to create, reduce that latency, we need to have that particular reducing memory copy. We need to free the buffers, and then we need to integrate into our whichever system we want to put it upon. So that's what we are trying to do. We are trying to reduce the number of memory copies from CPU to GPU, and whatever possible at GPU's end, except input and output operations, everything starting from your receptors of the sensors to the deployment, everything is running on GPU. And that too, the GPU is for your application, right? So we have come up with the deep learning accelerators. These accelerators, you can offload your deep learning models to these deep learning accelerators. The vision accelerators are there, which is PVA. So that part, you can, all the vision accelerators like OpenCV, CUDA or OpenCV, these kind of libraries, you can offload it to the vision accelerators. The application part, you can have it, the whole GPU to yourself. So that's what our goal is. We want the, if any questions, go ahead. This is all I wanted to tell.